So here we are in Chavín de Huántar, facing one of the many problems, challenges, but real opportunities that exist in this site. I'm seated on a bunch of rocks that fell down from a high wall in back of me in about 550 BC. We think it was a significant earthquake that's really damaged this site in a major way, and it brought down most north-south facing walls, or north-south running, east-west facing. And this is a great example of them. So we've been excavating here and we've cleared the rocks off. And we've been able to pull out some of the dirt between them, but yet we are still faced with an amazing rock pile. Rocks that fell 2,500 years ago. So we would really like to see what's underneath these rocks. They probably fell very rapidly. We think the wall collapsed in this earthquake. And there wasn't probably time for any of the Chavín people, the ancient Chavinos, to do anything about that. Whatever was on the surface that my feet are on right now stayed there. Now, it probably was pretty smashed up, broken beyond a doubt. But if there was any ritual paraphernalia, if there were any distributions of artifacts, even refuse from sacrificed items, they should still be there. There's the realistic, but probably remote possibility that there might be a few people underneath these rocks as well. From what we can tell, they were never moved. But we face a big problem. Number one, moving the rocks. We're working on that today using a series of pulley systems, chain hoists, cable pullers and such to try to move rocks out of this depressed excavation area that we're currently in. And that's a practical problem. We can overcome that. Chavín people of today know how to move rocks using equipment and using brute force. But the problem is that these rocks fell from a face of a wall, which was in back of me, and they still retain a directionality, a common direction, north-south, in accord with the wall they fell from. That means they've still got a lot of information. They can tell us something about how far they fell, when they fell, in what order they fell, and maybe what the wall's like that they fell from. We think that fairly few of the large blocks have been taken away. Can't prove that until we actually have done more analysis, but that's just what this challenge is about. How are we going to analyze this distribution? So, a number of things we need to do. One is we need to have a tremendous record for each one of these rocks. A rock cannot be lost to us. But of course we can't take it to the lab either, because many of these are weighing 1 or more tons. So we have to leave them out here in the field, pull them off to the side where they're not in our way and they don't get in the way of people visiting the site. But what we want to do is record them. So how are we going to do that? We can record their position without too much trouble. We take our total station, our surveying instrument, and we can record where their positions, say their corners are, within the coordinates of the site. That's good. But in none of these recording of coordinates can we fully map the rock, because part of it's lying underneath, and moving ton rocks around just to figure out what their shape is not easily done. But what we can do is photogrammetry. We can take a series of pictures around all sides of the rock. In practical terms here, we take one side of the rock, we flip it over, and we take the other side, and then we use that to make a 3D model. A model that will give us the exact geometry of the rock in scale. So that's one of the many pieces of information we then have. What do these rocks look like? And we can look at all sides of them. We can make a pretty good estimate of which was the side that faced out in the wall, which were the sides that were lying down on another rock and had another rock put on top of them. These things make some sense. we can also figure out what rock we're looking at. The great majority of this is limestone, and that's what the great majority of Chavín walls are built of. But they also use, for certain purposes, limestone, mostly for cornices that projected out from the walls. And then we have as well granite. This granite will be high in the walls in most cases. But we can note where these different rocks are in the rockfall area. So we're starting to build now a database. Exactly what the rock is shaped like. We've got exactly where the rock was from. We've got exactly the resting position of that rock as we found it. And we can estimate more or less where along the length of the wall all this was. We have one more piece of information that really gives us a chance to make some sense out of this. And that piece of information is, what is the logic of construction of the walls? How were these walls put together? They're not just a series of rocks stacked on top of each other. There are a whole lot of rules involved about which rocks will go where in the wall. And so we're trying very hard to make a rule book. It says when the Chavín people built this wall, because we have an extension off to my left here of that wall still intact, where it did not fall, or at least the lower portions did not fall. So we can build up the rules. So now we have a whole lot of information about the rocks that fell out of a wall. But we want to do something with that. And so one thing that occurs to us in this day and age, of course, is artificial intelligence. If we could take all of this massed information and then make a best estimate of where these rocks, given their raw material, their size, their resting position, all of this, where they would have been in the original wall. That would be pretty darn neat. And so that's one of our real goals here, is can we virtually recreate the wall? If we were tremendously successful in doing it, and the solution for where these rocks came from was unique enough, concrete enough, we might think about rebuilding the wall. But that's for another day and time. Right now, I want to know what this wall looked like. And we could take these blocks and reassemble them virtually, put them up in the wall, and we could even have people visit here and look at that wall and see above the little traces of it that are down at the foundation level what that wall looked like. Got some great options there. So another thing we can do is finite element analysis, treating these blocks of stone as individual pieces of stuff to which energy would have to be subjected to get them to where they are now, from where they had been. This might be able to estimate the grade of earthquake that brought them down. It might be able to tell us a whole series of things about what's happened to them since they were in the wall. But basically, I think we're trying to do something that hasn't been done very much. In archaeology, many people have tried to reconstruct, say, pottery from broken pieces with the help of a computer. It's a very finite problem. In this case, we've got all these different elements of information about these stones and what happened to them that are coded in where they are, what they look like, how they're resting, and what they're made out of, and what we know about how Chavín people built their walls. We think that if you put all these together, we ought to be able to come up with a small number of solutions to what this wall is, if it were all put back in place. So that's what we have for probably the next 3 to 5 years here, working as one of many of sub-projects that we're doing. But this one I think is particularly fascinating. It's got a lot going on. I think it's going to need a lot of help from a lot of people who know more about things like artificial intelligence than I do. From geologists, from engineers, from people who know about various programs that can take the same data and give us different types of information. So, as of now, we're off and running. In a few years, I hope to be able to tell you what it all means. Thanks.